application security engineer at Netflix. I do a lot of security and data visualization research, and also love to travel.
Cool. So what are we here to talk about? We're going to be talking about Ensnare, and we're going to be kind of walking through why we decided to go through the arduous process of writing this utility, and kind of how it works and how you guys can use it in your projects, or use some of the logic we came up with in your own projects that aren't specifically written in Rails. Actually, before we kind of finish with the slide, I just want to poll the audience here. Who works in application security? Maybe you're an application engineer, you do testing. Can we get a raise of hands? Okay, excellent. How many of you guys do network penetration testing? You're more on the network side. How many people are compliance, audit, that kind of stuff? Okay, excellent. Developers? All right, sweet. So Ensnare is an open source Rails gem that provides web application attack detection and response capabilities. And it's also a gem that requires minimal configuration, yet it's super customizable. We'll get into the details here, but if you guys want to grab the beta, that's the link. We just recently open sourced it a few days ago. We need people to test it, so please check it out. So why are we actually here? This is just a small subset of the companies since January 2014 that have had data breaches, right? So, and as we all know, we're all in high demand. We're all definitely employed, hopefully, and we've noticed that things have gotten pretty bad. And there's a lot of reasons that this is kind of the case. It seems that data breaches are more frequent and severe. There's a quote from Wade Baker here, who is one of the co-authors of the Verizon data breach report. He states that attackers are getting quicker at compromising systems over the past 10 years, that bad guys are winning at a faster rate than the good guys are winning. And I pretty much agree with this statement. I think we have made some advances, especially in the application security side. We've seen some advances in the way that browsers handle security. We've seen cool technologies like content security policy, I'm sure some of you are aware of, and other things. But overall, we're still running into a lot of problems. And these problems are kind of around the actual complexity of the attacks. We have things like traditional attacks, SQL injection, cross-site scripting, cross-site request forgery. And really, these have been vulnerabilities on the OWASP top 10 for the last 10 years. We have seen cross-site scripting be just as prevalent as it was in 2002 as it is in 2014. I think White Hat ran a scan, maybe it was last year or the year before, said roughly like 40 to 50% of the web has some sort of cross-site scripting vulnerabilities on it. It's really not winning at some of the stuff that seems relatively easy to fix. We also have issues with business logic, right? With these complex applications, and we might identify a vulnerability. Maybe it's multi-step, maybe it's a multi-step attack, or it's something that requires a little bit intimate knowledge of how the application works. And if you're an application developer, someone that maintains those applications, how do you actually detect those types of attacks? They cannot, sometimes they don't even necessarily look like security bugs, right? That we can write a signature for. We also have issues with direct object reference, right? This is prevalent. How many times have you guys on an application assessment saw an identifier and you enumerated it one or you decremented it one, right? And maybe you got access to somebody else's account. We have tons of issues with authorization and authentication and distributed denial of service attacks. And a lot of this really falls into the application complexity, right? The way that the web used to work is we served up some static files and it was kind of a two-tiered system. Now we have all these components that make up an application stack that give the attackers a lot more room and flexibility to actually poke stuff. And here at Netflix, we do quite a bit of agile development and continuous integration. This means we have a lot less time to actually catch vulnerabilities and remediate them. So we may be having an application that view is completely different for you and is completely different for you, and we're running actually different code bases based on your geographical location. If you're in a particular A/B test that we're currently running, this stuff turns on and off at a really high frequency. So how do we actually detect and respond to all this? And I think that the solution that, as a security industry, we feel like is the way to solve this is just to throw an appliance at it, right? And this is a quote from Ted, who I think works at Shape Security Industry. He stated that the industry just needed a bot wall. Does anybody know what a bot wall is? Anybody heard of that term? Do you guys think we need a bot wall? So, I mean, I think we kind of run into this sort of issue right here. It's be a little bit hard to read, so I'll just read you the slides here. It says, so tell me again, why do we need your security appliance? We already have a WAF, load balancer, firewall, bot wall, and a behavior analytics engine. Yeah, but ours, the lights are blue. Give me all your money, right? And that seems to be kind of a general statement. We just keep engineering solutions that are maybe appropriate, but also relatively complex. And so Andy and I's philosophy is that application security really starts in the application. So things like secure coding, security awareness, doing security assessments, these are things that are number one. They're really going to allow you to effectively identify and remediate vulnerabilities within your applications. And some of these new tiers and appliances, they can be useful, but a lot of times they really do increase the complexity of your stack. And a lot of times they actually mask underlying problems instead of solving them, right? So maybe they provide some sort of mechanism, but at the end, you're not actually fixing the applications themselves. And so we really feel that the best place to actually identify and handle attacks are often within the application itself. And so one of the things I want to do is kind of take a look at what attacks actually look like. And it really depends on the techniques that are in use. If we kind of break attacks into two categories, and we'll just say manual and automated. We have manual attacks that are slow and targeted. We have automated attacks that are fast and all over the map, right? And so how are most of these web vulnerabilities exploited? In both circumstances, it's really a manipulation of headers and cookies, parameters, path, order of operations, the steps at which you're assessing the application. So in general, you really have to identify a vulnerability in order to exploit it. So if we take a look at automated scans, these are typically easier to detect. And there's a variety of factors for that being the case. There's a higher velocity of requests that's going to be hitting the web service, for example. There's going to be many unusual and invalid requests. There should be also many requests for pages and functionality that doesn't exist. So this kind of scanning logic for automated scanning is, either you're going to manually browse or spider the site and kind of define your scope. You create some page exclusions for things that you don't actually want to scan, like logging out or maybe some read-only area of the site you don't think is going to be interesting. And then you're going to inject faults and examine responses for signs of vulnerabilities. And so I kind of walked through, this is also going to be a little hard to read with the monitor here, but I'll kind of walk you through what this is. This is just me kicking off a targeted burp scan on a particular page on Netflix. So the first thing that we see is a sanity check. Burp facilitates 2 requests to a particular page. The reason it does this is eventually it's going to use these pages, most likely the HTTP status code, the size of the response, all that kind of stuff, to help it with attacks like SQL injection or time-based SQL injection or Boolean-based SQL injection, all that good stuff. It's also going to do some policy and HTTP checks. So it says, hey, is trace enabled? What does your cross-domain policy look like? What does your CORS policy look like? And it's going to kind of check some of that stuff for you. It then goes through and does parameter checks. And it does this sequentially. It takes a list of your parameters and it injects a list of attack strings in each parameter until it finishes the list and it moves on to the next. It does the exact same thing with cookies and headers. So what can we really learn about this? Well, we can learn that scans have a predictable behavior. Now this is just burp. Some of the scanners do provide some sort of variance in what they're attacking when. But burp tends to be one of the scanners that, at least when we look through our logs, a lot of people are using. I think it's just because it's so cost effective. We also see that they first check policy files, they check parameters, they check cookies, they check other headers and refer, and since they progress linearly, we can kind of maybe potentially detect something with that. So what about manual testing? Well, with the manual testing, we're going to use a combination of browsers, proxies, scripts, command line tools, all this sort of stuff. We're going to do targeted scans. Often we maybe see a page with 30 form parameters, and we don't want to test cross-site scripting on each one, so we kick it to a scanner to let it do the work for us. But in general, testers are looking for user input that's being handled unsafely. And also looking for things like business logic vulnerabilities. What are the unexpected and edge cases of the site? Where can I manipulate something that's going to actually change the behavior of how a response handler is going to render my response or do something with the data I'm providing? Where is my data actually touching a file system, touching LDAP, touching SQL, for example? We're also going to look for hidden and less visited areas of the site. Does something exist at /admin, for example? So our observations we can make on a manual observation, we could say, is that exploit attempts, they probably seem a little less random, and they're also going to be a little less frequent, right? Because a lot of times you might just kind of be browsing the site to learn how the thing works before you start facilitating attacks. This could be a lower velocity, but still the same basic techniques and detection strategies exist. And so how do we typically attack this stuff, right? Or detect these attacks? We use things like signatures, right? We all know we can bypass signatures, but they're often in place. We use things like exception handling, like an invalid path or an incorrect data type. Hey, why is this all of a sudden a string? It should be an integer. We do things like existing security functionality checks, like we build an authorization. If somebody tries to access your account, maybe we have a check in our Rails code that says, no, you shouldn't be able to do that. It displays a warning message for the user. But what about else? We want to talk about the concept of honey traps. So what honey traps are tripwires that dynamically change and entice an attacker. They have no impact on underlying application functionality. They also allow you to take notice of bad behavior. So let's actually walk through an example of what this looks like. So here we have a request I'm making to a page, and I see a cookie that says admin equals false. What are you guys going to do if you see this on an assessment? You're going to probably flip it to true, right? Maybe this is a pretty obvious example. Maybe you might feel a little suspicious, like why the hell is admin set on here? You're going to flip it anyway. At least I know I would, right? Now, however, this cookie actually has no impact on the application functionality, and we'll kind of walk through how Ensnare takes use of this when Andy starts speaking soon. Now, we'll take a look at parameter here as well. Here's a parameter that says, it's in the user model for this particular page for signing in, and has a UID set to this. Who is going to increment this by 1, right? Or is it going to try to access account 1? I totally would. I'm sure you guys would too, right? And that's something that also has no impact on the underlying functionality, as this is just a honey cookie, or a honey parameter. So there's actually been a little bit of prior work in this space. Mod security has some of this functionality built in. It does require you to have mod security, so you have to have that in place. And you have to spend quite a bit of time actually configuring where you want to stick the traps and on what pages and requests. App Sensor is a project that works specifically for Java. It's really awesome and powerful, but it hasn't been updated in a few years, and it doesn't look like it's actively maintained. Mykonos is a commercial product that does this, and there's also some other WAFs and IDSs that provide similar sorts of functionality. But we felt that there was a couple elements that were missing. We wanted something that was super easy to use, something that we could get up and running on a Rails application in, I don't know, less than 10 or 15 minutes of mucking with. We also wanted something with advanced response handling. We wanted to make it really annoying and painful to assess these web applications. And we'll walk through some examples on how we do that. We wanted something that was extensible so that you guys could contribute to the project and write your own modules and push code up to our repo, and we could all work on it together and have a really awesome system. We wanted to be able to collect metrics too, to kind of learn about what sort of attackers are using against web applications, and use that to further go back and extend AppTrap to be more effective. Ensnare. This works directly at the application layer, so it sits right inside the app, and it's effective at thwarting both automated scanners and manual testing. That's our awesome logo. So how does it work? As I kind of mentioned before, it sits alongside the application. It examines the requests that come in, and it looks for bad behavior, which we call violations. And we'll kind of enumerate what violations are and how they're triggered within the application. It responds to the bad behavior. Now, this is optional. Maybe you just want to log the information, or maybe you want to redirect the user to Disney.com every time they make a request for the next 5 minutes. You can do both of those things within Ensnare. You can also set traps on the responses to catch the hackers. So once the response is finally rendered, you inject those traps, hopefully enticing them.
So I'm going to start out here, and we're just going to walk through kind of at a very high level what a standard web application looks like when someone is interacting with it. And again, this is very high level, but basically when I make a request with my browser, the server is going to receive that. It's going to figure out what the user was looking for, and then it's going to render some type of a response. So what Ensnare does is it adds a couple additional steps to that process, right? So we'll walk through each of these, but basically once a request is received, it's going to check for violations, determine the threshold, run the responses, set any traps that are configured, and then finally render the response. So let's walk through each of these steps so that you kind of understand what I'm talking about here. So the first step is after a request is sent, Ensnare is going to receive it, and it's going to check for violations. And what does that mean? Basically, it's going to look and see, is this request somehow malicious? So does it match a signature that we've set up? Is it to a bad path? So is it to some page that doesn't exist, like /admin, or some WordPress login page that we're not using WordPress, so it's not valid? Have they triggered a trap? So Scott gave a couple examples, like an admin cookie. Has that admin cookie been changed, which would never happen in the normal use of your product or your application? Or is there some other custom logic that you've set up? So maybe you have authorization checks. You can hook into those and look for users who are violating your authorization expectations and trigger violations from that as well. So at the end of this step, if there's any violations that have occurred, so if any of this bad behavior has been noticed, we're going to log that information. The next step is determining the threshold. So basically what we're doing here is we're just saying, okay, so based on this request that I've received, I can figure out what IP address it's coming from, what user it's coming from, and their session ID, and I can come up with an aggregate number of how many violations have been logged for this requester. And then based on that and the configuration, which we'll walk through a little bit later, we can determine how bad we think the user is and how we should respond to them. So step 3, and that's actually run the responses. So these are optional, but essentially Ensnare allows configuring a bunch of different responses that can be run for bad users only. So for example, maybe we want to modify the response that comes back. So we see an attack come in, someone's trying to exploit SQL injection on our website, and instead of rendering whatever the native response would be from our application, we're going to send them a 404 message, or we're going to send them a 500 server error message. Maybe we're going to just send them a message back that says, hey, we know what you're doing, we'd appreciate if you didn't attack our site, or we've noticed this security exception, our security team has been alerted, or who knows, maybe we just want to send them some message so that we can say, hey, we're on to you, we know what you're doing, and that might be enough to get them to move on somewhere else. There's also, it's totally customizable and extensible, so you can essentially insert any type of code you want to run here. It can modify the response like a message, or it can replace it entirely. And we'll talk about some more examples of what you can do later. Step 4 would be to set the traps. So we talked about a couple different types of traps that are available, honey cookies and honey parameters, and that happens essentially right here immediately before the response is run. And then step 5, going back to that initial diagram, would be actually rendering the response back to the user, whether that's the Ensnare provided response like a 404 page or the application response. So now we're going to go back and kind of walk through some of these concepts in a little more detail. So violations were the first thing we talked about. So what exactly are the violations that Ensnare detects? At a high level, they're just instances of identified bad behavior or potential bad behavior. And we track those over time and we aggregate them. And they can be triggered by things like I mentioned earlier, visiting a bad path or a path that doesn't exist, putting an exploit string in one of your requests, tampering with one of the traps. And based on the configuration, we allow them to be weighted. So maybe a lot of your users hit 404 pages quite frequently, so maybe that is kind of just a minor violation. But maybe when you see something like SQL injection attempts, you want to weight that as a very bad request, and you want to count that against the user much more. So Ensnare allows you to set that up in your configuration. Kind of as I mentioned, violations are tracked in a database table, and they can be tracked based on the IP address, the session ID, and the user ID. You can also use any combination of these. So if you turn on all 3, basically the violations will be logged against all 3 of these. And then it kind of gives us a good way to be able to determine, is this user still attacking us from the same user account, but they're hopping IP addresses? Or maybe they're on the same IP, but they keep generating new user accounts because we keep locking out the initial user account that they set up. So basically by aggregating all of this based on all 3 of these, we think it makes it a little more robust, and we think it allows tracking things even if the attacker is doing some kind of tricky stuff to get around our protections we have in place. So the next step that we were talking about was determining the threshold. So this is basically determining how bad we think the attacker actually is. And we want to make sure that when we're running any type of responses or we're giving any type of response back to a user, that we're being careful about distinguishing between a general user who maybe mistyped a URL and an attacker who is repeatedly trying to exploit vulnerabilities on your site or running a web application scan, for example. So the thresholds that are built into Ensnare allow this flexibility. So essentially, when you configure Ensnare, you can set up any number of thresholds you want, and they can respond to the user in a lot of different ways, which we'll go into a little more later. But really, at a base level, the thresholds allow very powerful state handling and tracking of people who are attacking your website. And based on that, you can do a lot of different things. to try to get the attacker to go away and stop attacking you, or go somewhere else and leave your site alone. So, things like confusing the user, eluding the user, distracting them, or just slowing them down. You could make responses that created false positives or false negatives in a scanner log, all while having no impact on legitimate users. So basically, the thresholds are kind of there to allow you to set up some different states that an attacker can get into, depending on how much and how long they've been attacking you, that really make it very difficult for them to determine what vulnerabilities are on your site, and hopefully just go away and attack someone else. So there's a few different attributes that can be set up on all of these thresholds. So number one is the trap count, and that's just essentially how many violations have to occur before a user falls into this threshold. There's a timer, which basically states once a user has entered this threshold, how long are they going to stay in it before their responses go back to normal. And then finally, the responses. So how are we going to respond? How is the site going to behave for this user once they've entered into this threshold? And to demonstrate this, we have a little diagram here. You probably can't read that, but I'll kind of walk through what this all says and what this means. So we have an attacker up at the top who starts scanning our site or manually testing our site. He's trying to find SQL injection. He's trying to find cross-site scripting. Eventually, he racks up 5 violations. So essentially, we've identified 5 different times he's tried to attack the site. At that point, based on our configuration, we'll move him into trap threshold 1, which will last for 600 seconds after his last violation attempt. And while this user is in trap threshold 1, his responses are going to look different than they would normally. So 20% of the time when he makes a request, we're going to delay that request for 10 to 15 seconds. So he's going to make some request, maybe it's legitimate, maybe it's trying to find a vulnerability, and instead of responding to him right away, it's going to be delayed for 10 to 15 seconds. So obviously this gets really annoying. If you've ever manually tested a site, when suddenly it's just really slow and it's really hard to use, this gets very obnoxious and it makes it really difficult to accurately find vulnerabilities in an efficient manner. 30% of the time we're going to redirect him, we're going to send him back a 301 response and just redirect him to the root of the site. And then another 50% of the time we're going to do nothing at all. So you can kind of imagine if you're testing the site, you've found a couple things or you've tried to find a couple things and all of a sudden the site starts delaying you, it starts redirecting you, but it's all random, it's going to get very frustrating, right? So he continues and eventually he gets up to 20 violations. And at that point, we move him into trap threshold 2, and this time it's going to last for 1,600 seconds after his last violation is logged. So in trap threshold 2, it's going to respond a little differently. Now we're going to delay 60% of his requests for 20 seconds. So now all of a sudden the site is even slower for this guy. It's still working, occasionally, but it's taking a lot longer for him to run his exploit attempts or his, vulnerability identification attempts. And it's getting more annoying. And now for 20% of the requests, we're going to give him a 500 error now. So now instead of redirecting him occasionally, we're just going to send back a 500 server error. So this is something that sometimes attackers find kind of interesting because it can indicate that you've identified some type of a problem in the logic of the site, but we're just doing it randomly. So it makes it really difficult for the attacker to put any correlation between the requests that they're sending to the site and the responses that they're getting back. And then finally, 20% of the time, we're just going to do nothing, which means we're just going to render the response back normally as if nothing else was going on. It's going to be the application's standard response. So that's kind of how these trap groups can interact, basically. Again, based on the user's violation count and based on the configuration of how long you want them to stay in the trap group and what different responses you want to run in them, you can set these up to be very layered and interesting and very confusing for someone who's trying to attack your site. So again, we have some text up here that's kind of hard to read. This is just kind of an example config that we wanted to walk through in some very brief detail just to give you kind of a sense of how this gets configured and what you can do with it. So in this configuration, which you may not be able to see, this one has a trap count of 15 violations. A timer of 900 seconds, meaning the user will stay in this trap group for 900 seconds after the last violation. And then we have a couple different traps set up. So first, if we see a violation in a user's request, we're going to send them to a CAPTCHA page that makes them solve a CAPTCHA before they can continue doing anything else on the site. So they'll get a CAPTCHA, and if they try to go somewhere else, they're just going to be redirected back to that CAPTCHA until they actually solve it. So that's one of the traps. And then we also have things kind of like we mentioned on the previous slides, redirecting to the root or to some other page 10% of the time, throttling so that the requests take between 15 and 20 seconds to respond, 404 pages, 500 pages, creating a redirect loop, so that's another response that you can do. Basically, just start redirecting them to a page over and over again with different parameters. That's kind of cool because it fills up their proxy logs if they're manually testing. And again, it really doesn't make any sense to why this is happening. And then 20% of the time will do nothing. So these are some of the different responses that can be set up. Again, each of these can be weighted as far as like a percentage of the time or a frequency that you want this to happen to the user. And then there's always the option of doing nothing, meaning just rendering the response back as normal. So, we've talked a little bit about some of the things that you can do, but the responses are really just techniques to prevent the attacker from being successful at trying to exploit your site or find vulnerabilities on your site. So, we want to do things like slow the attacker down, alert them that we understand what they're doing and we'd like them to stop, blocking them entirely. So that's, of course, an option, just not allowing them to access the functionality on your site. Or maybe you want to do something like send an alert to the security team so that they know that this type of an attack is ongoing and they can take some other manual action if they want to. And then there's always other options that we've talked about. So annoying the attacker, just send them to a CAPTCHA page repeatedly. That gets pretty annoying pretty quickly. Or maybe we haven't implemented this, but maybe you want to hack the hacker back, right? So maybe if someone does a certain level of bad things on your site, you're going to inject a beef hook and start gathering information about their browser and their location and things like that. That's certainly an option, although we did not implement that. So each of the responses that we've talked about has a number of different configurations that you can set up, and each request can trigger multiple responses. So we kind of walked through some of the options that can be provided. So for example, the throttling option, you can set it to throttle between two periods of time, so maybe between 10 and 30 seconds. And as we discussed earlier, responses can be configured to run on a weighted basis randomly. And then we get to the point where we need to set traps that we want to send back to the user. So we kind of talked a little bit about what these are. They're things like setting up form parameters that are not really meaningful to the application, but we can check for them being tampered. The same thing with cookies, right? So we might set an admin cookie that's set to true or false so that we can see if the attacker changes that. Since most normal users are not going to even see that data, it's unlikely that if that's being changed, it's from some normal user on the site that's not trying to identify a problem. Same thing with the parameters. Essentially, we can inject some hidden parameters inside forms, and we can see if they're being changed. This is great for both manual attackers if they're kind of lucrative looking, but they also work well for scanners, since the scanners are essentially going to enumerate all the parameters on a form and then tamper with all of them. And a lot of times that's done in linear order, so we put our parameters first. So essentially, a lot of scanners, when they see your form, they're going to come to these honey parameters and they're going to start tampering with those first, meaning we're going to kind of catch them in the act before they even get to testing anything that actually impacts the functionality of your site. And we wanted to have a couple notes here on just different ways you could approach using these things. Obviously, there's the example we've given before, using lucrative names like admin or debug or CSRF token, UID, things like that an attacker is going to look at and say, hey, I want to change that and see what happens. So that's obviously one option. I think, especially for manual testers, that's likely to be something that's going to draw them to them. And then there's also the concept of using benign names or names that are not quite as lucrative, but maybe would be a little less obvious that they are part of the security functionality. So things like Garo or just random stuff that you could use. And essentially, I was going to say there, you can configure these to be anything you want. So if you have a set of parameters you want to inject, you can inject anything you want. They can be any value, and they can be randomly generated with each session.
Cool. Okay, so we'll do a quick demo here. And so it's probably a little hard to read. So I'll just kind of walk through what's going on. On the left here, we have this website, Insecure Widgets, which is a web application that Andy wrote. It's got pretty much the OWASP top 10. There isn't like a single page in here that doesn't have a vulnerability, basically. On the right, we have Burp Proxy that's set up to proxy the site. And so we kind of imagine the attacker here is going to visit the site and doing what you might typically do, kind of getting a feel for what's going on. So users browsing the site, searching, kind of just doing a variety of stuff, hitting some pages, and really just getting more familiar with it. And so at this point, Ensnare's not really doing anything because the user's not doing anything malicious. They're browsing just like a normal user would, right? They're not touching any cookies or parameters. But I see an interesting request here that I want to take a look at. I've identified a cookie right here that I think is interesting. It's probably a little hard to read in the back, but it says admin equals false, right? So that could be potentially interesting as I'm looking through my proxy log here. I also see another interesting thing here, coupon code. Okay, so that's kind of cool. It is a shopping cart site, so maybe that's something I could potentially play with. I'm going to go ahead and send that request over to Repeater. And I'm going to go ahead and make that change to that particular cookie value. So I'm going to switch admin to true. I facilitate that request. I get a 200 back, so cool. It looks like it went through. What actually happened on the back end is we logged a violation for that. Now the user goes back, wants to continue assessing the site, maybe even checking out, oh, but it's weird, I got an error there. So it seems that I got some sort of error. Let me try something else. Oh, I received another error. So this is a little odd. Things were working, but now I received another error. So I try to facilitate. Nope, now I got a 404. So I was getting some 500s. Now I received a 404. To proceed to check out, I got another 500 error. I got another 500 error. Another 500 error. So right, I'd be pretty annoyed at this point. Okay, this request looks like it's going through. I got a redirect loop. Are you serious? Like, where did that come from? I take a look at the proxy log here. Also a little bit hard to read in the back, but we'll kind of zoom in. I get some 500s, I got a 404, some more 500s, and then an indefinite 302 to a particular page, filling up my proxy log, confusing me. I have absolutely no idea what's going on. Now, we can take a look at the dashboard here and actually look at the metrics, and we see that that one violation was logged for the IP address and the session ID. I can actually go through, it's a little hard to read, but I can see what the expected value and the observed value was. That's kind of useful because we can start patterning and kind of learning some stuff. What are attackers actually throwing at the site? What kind of stuff are they looking at? Is there certain cookies that are more interesting than others? So we wanted to kind of do a little CTF thing. And we highly suggest you guys play with it. So we launched an application, a cookbook app on Heroku. The link is ensnare.herokuapp.com. We would love to get you guys playing with an application that's protected by Ensnare. This is not a production app. We threw this together real quick, honestly, like a day before we gave this talk in InfoSec Southwest. We spent all night getting it all up and running and writing the app and everything. So there's a little rules. Don't DOS it, please. And don't kick a super evented scan against it that's going to knock it down. It's on free Heroku, so it doesn't have a ton of memory. Scanners are okay though. You can scan pages. And we'll give you guys super extra points for authorization attacks. If you guys can compromise somebody else's account, delete somebody's post, delete somebody's recipe, change somebody's comment, I'll give you mega points, and hit me up on Twitter if you do end up doing that. So what it looks like is this kind of janky recipe app where you can leave comments. Sorry, the resolution here is kind of ridiculous. You can log in and log out. You can create your own accounts. You can look at recipes and add comments. Steve has terrible recipes. I'd delete them if I could. Hint, hint. And yeah, that's basically it. So we would love if you guys played with that. So one of the questions that's probably rolling around in your minds is, does this have a performance impact? So we derive these metrics using YSlow, which is a framework to kind of measure basically response generation latency. We noticed that on average, the difference between pages protected by Ensnare and not Ensnare was 10 milliseconds. Spoke to one of the engineers over at GitHub. Their average response time is right around this for most page requests. It's about 150 milliseconds. Some of their page requests take about 300. So that's an average difference of 6.7%, so roughly 10 milliseconds. So, I don't know if that's something that we'd actually be able to, you'd be able to notice, especially with how inconsistent network latency is on the web. I don't think you've probably noticed. So kind of the deployment strategy for this is we have the documentation listed right up here on the project page. We also have a wiki that kind of really walks through how this whole thing works. There's a configuration file that's highly annotated. I got it, I'm good. We have a dashboard that provides example configuration files, so you can actually take a look at the dashboard. I'll pull it up for anybody who wants to see after, and we can kind of walk through what that looks like. We'd also suggest once you kind of read through it, just start it in log-only mode. Just log violations for a while and see how that looks. Then make some tweaks and you can actually turn it on enforce. When it's in force mode, that's when all the fun stuff starts happening. And so we just had a couple of final thoughts. In a sense, the honey trapping elements of Ensnare are obscurity, right? So this is something that gets a bad name in security, but our thought is that if you've ever been on an assessment where things are really annoying, like your effectiveness at actually getting full coverage of the application is limited, right? So this does have a place. When it's layered on top of secure coding, this is not a replacement. This really just needs to be an element that you put on top of the stack. The fact that we can actually hook into existing checks and rails makes this also not obscurity. So when you hook into authorization checks and you log violations that way, you testing an application looking for direct object reference, business logic vulns, you could potentially trigger violations unbeknownst to the user that there's anything going on and perform the same sort of advanced response handling. So basically, if it dissuades an attacker enough, it really becomes effective as a WAF. We have a couple of to-dos. We want to do Rails 4 edition. We'd love to get this working on Git parameters. Currently only works on posts. We'd also like to get it working on other headers. We have the idea of threshold start delay, which is kind of like once you enter a threshold group, waiting some amount of requests before you actually start enforcing it. It'll just make it harder to correlate what's causing you to get into a weird app state. We'd like to do whitelisting for user accounts, IP addresses, especially for testing. More response types. Somebody should write that beef hook. That'd be pretty sweet, right? Hack the hacker. Just a couple of caveats. There's no traps on Git parameters. We don't currently have test coverage, but that's something that we probably go back and have to do at some point. And then just a couple of configuration tips. Make sure your trap names are intelligent. If you're setting a coupon code on a site that doesn't have a checkout, that doesn't make any sense. And your threshold groups need to be intelligent. Don't block legitimate users, and maybe don't go as crazy of a threshold group as I created in the demonstration. Maybe a little more subtle will work. And that's basically it. You guys have any questions? I think we have a couple minutes. Yes?
So have you guys considered the case potentially of an attacker that attempts to besides the site is using this that attempts to use this particular functionality to denial of services against a legitimate user?
For legitimate users, yeah. We see that as being basically the same as a cross-site scripting attack or like a CSRF bypass. So, if we have, since we don't actually do it in the GET request too, like we're not currently doing like honey trapping in GET requests, that attacker would have to identify what's causing that violation. They'd have to trick that user to visit their malicious site. It's kind of the same that we'd see in a CSRF or a cross-site request forgery. So we feel as though that possibility exists, that it really has a lot of the same sort of, it's basically the same as a user would typically attack somebody with a cross-site scripting vulnerability. Somebody else had a question? Yes?
Yeah. Thank you. Actually, I have more than one question. So on the misdetection versus false alarm rates, okay? For instance, a user who has a misconfigured system, is it possible that they are going to end up with this bad experience even though they're innocent bystanders?
One of the things that we take advantage of is the browser, right? So parameters and cookies, post parameters and cookies are only manipulatable through a proxy or some way of you messing with the traffic. So our expectation is that a typical user that visits the site, as long as they're using a browser, should have a normal experience.
So what if they attempt to access non-existent pages? Does that set off the threshold?
That could be, you could configure it or you could not configure it. So for example, in our demonstration, we have /debug as something we don't let them configure, but if they hit another 404, they don't get an error. So unless the user goes to /debug, then we would kind of log that as a violation, but you don't actually need to do that either. If you're a lot of your page users hit 404s, you can just say, I'm not going to log traps on that particular type.
Also, it seems that a lot of your parameters are temporal based. So if somebody comes up and knows about your system and now uses low and slow type attacks, will they get under your thresholds?
Yeah, potentially if the timers are set to expire in a certain way. So if they're kind of just slowly poking and attacking the site. But we'd also assume that those same attackers, even if we sort of saw that sort of behavior potentially, you could just increase the timers. You could also increase the threshold severity for the types of attacks that they were trying. So maybe if they're trying to do a direct object reference vuln, you weight that extremely high and you move them into a threshold group that maybe lasts for 24 hours, for example.
Okay. And I guess the last question is there some kind of signature that you know of that you're giving out that would make the presence of Ensnare detectable?
I'm sorry, could you say the last part again?
Is there some signature that the attacker could hook into that would indicate that Ensnare is present?
Absolutely. I think if you picked really bad cookie names, for example, but maybe potentially some of the predefined ones we shipped with the project, after a while attackers might start identifying those as being honey traps. One of the things that we could do to kind of get around that is to maybe use some of the honey traps, but also potentially not use any honey traps and just work Ensnare into your authorization checks within your application, making it much harder to identify that there's something there.
Yep.
Since those checks will basically be happening behind the scenes and won't change any of the request or response, or won't change the information the attacker sees when facilitating the request.
It's like any other security product. The default functionality might be kind of obvious, the Cisco password type issue. But basically every piece of this is flexible and customizable. So the parameters that you use can be customized. The cookies that you use can be customized. The responses that you use can be customized. The things that you actually look for, all of that can be changed. So if you're doing kind of a custom configuration, it'd probably be pretty difficult to determine with certainty that this is what you're using.
Good. Cool. Any other questions? We'll be hanging around, so if you guys have any other questions, come see us. Thank you.
Applause for. Please fill out your surveys, and I'll be in the back of the room, and I'll be glad to take them off your hands.
Thank you. Thank you.
Andy, right? Yep. Awesome. Thanks.